Hello and welcome to the latest in the what's become fortnightly series of CIBSE certification webinars. This is Andrew Gins, just setting the scene. Don't worry, I won't be speaking. Bit of housekeeping, just to let you know, we'll be emailing a recording of the webinar to everyone tomorrow, and we'll also get a copy of it onto our website, as well as a copy of the slides, or a PDF of the slides. We are settled into a fortnightly routine now. I've got July booked and one speaker in August booked, but if anyone out there is keen to volunteer, do let me know, because we like to book the rest of August and in September. So that's it with the housekeeping. Just like to briefly introduce Nishesh Jain. I'm sure he can build on the introduction himself. He's speaking today on repurposing a certification model for better design stage performance estimates, which is a very interesting title. Nishesh has been working on a knowledge transfer partnership arrangement with UCL and Design Builder, and I think the sign of a good research project is to ask the right question, and that topic suggests that Nishesh has. So that's probably enough from me. I'll hand you over to Nishesh, who can tell you exactly what he's covering today.
Thank you, Andrew, for the introduction. And so welcome everyone to this webinar. My name is Nishesh Jain. I'm a researcher at University College London's Institute of Environmental Design and Engineering, and currently, as Andrew mentioned, working on a knowledge transfer partnership project with between UCL and Design Builder software. I've been working in the field of sustainable building design for many years now, focusing on building performance simulations, operational performance assessments in buildings, and recently my research is looking at energy and indoor environmental quality of buildings, their balance and trade-off, looking at trying to calibrate models, etc. So hopefully, and this kind of partly links to my existing research progress, which is happening this particular topic. So compliance versus performance modeling. Compliance modeling is referred to as energy simulation that is undertaken for compliance with building regulations, such as Part L calculations in the UK. Most practitioners looking at the concept of the performance gap understand that Part L calculations are not reflective of how the building actually performs. But this point is not well understood in the industry. For this reason, SimCTM 54 has been developed to provide guidance for full and accurate estimation of operational energy performance at design stage. Using dynamic thermal simulations provide a more comprehensive prediction of what operational performance might look like. In this webinar, I'm going to highlight the difference between compliance modeling and performance modeling, explaining how to repurpose a Part L compliance model into a SimCTM 54 performance model. So in this webinar, I will explain to you the difference between compliance modeling and performance modeling. So I think the mic got muted. So after that, I will explain TM54 approach to modeling and its requirements. And in the simulation software, I will demonstrate repurposing of a certification model to a performance model in accordance with TM54 guidelines. Through this process, I will explain to you the various calculations and results that can better explain the building performance and enable informed design decisions. In the UK, energy models are used at design stage to check compliance with building regulations. The intention behind these regulatory compliance calculations is to do a comparative assessment and benchmark the buildings within the building stock. Consequently, compliance modeling has become a key driver for energy modeling of buildings in the UK. However, this has led to an unintended consequence. Results of energy models are not intended as predictors of energy use, but sometimes they are mistakenly used as such. The key reasons which renders Part L calculations unsuitable for energy projections are: first, the calculations and the reported totals in compliance results do not address all energy end uses. For example, energy used for lifts, escalators, catering, or for server rooms. Another reason is that standardized input parameters are used in the calculation depending upon the building type, such as power densities and schedules of operation. These may be significantly different in the actual building. Using Part L calculations as design baselines can lead to a perception of an inflated performance gap. The graph on the left, taken from TM54, illustrates this. Performance gap is a term which is used to describe the phenomenon where buildings use more energy than the designers thought they would. This issue is not restricted to the UK but has been seen globally. So, borrowed from TM54, this is a list that provides a simple explanation of differences between compliance calculations in the UK and operational energy use. These include differences such as inefficiencies in operation, occupancy, specialist activities, and load densities. TM54 has been designed to address these. TM54 provides building designers and owners with a clear guidance on how to evaluate operational energy use accurately at the design stage. It explains the importance of making an accurate estimate of the operating hours and likely occupancy of the building. It also emphasizes on the accounting of unregulated end uses such as lifts, escalators, small power loads, catering, and server rooms in the building totals. To illustrate this point, this is a case study of a school in London. The graph compares Part L calculation against actual performance. At first glance, the difference looks very wide, almost 5 times. However, the huge gap seen is an inflated perception and not the real gap between the intended and the current operations, because Part L calculations, as explained earlier, are not accurate design stage predictors. Repurposing the compliance model into a TM54 method-based model, a realistic design baseline can be created which accurately represents the intended design projections. And this is the actual gap found. Therefore, the performance gap due to technical issues and inefficiencies in the building and its operations is about 1.5 times as compared to the perceived gap of 5 times. Practical recommendations in TM54 can be broadly categorized into 2 types: recommendations for better calculations and recommendations for better presentation and explanation of results. Better calculations require use of dynamic simulation software and use of project-specific assumptions. A second area which TM54 focuses on is to present the calculated results for a holistic understanding of the stakeholders. This is done through scenario analysis, sensitivity analysis, and comparing the performance against other similar buildings, that is benchmarking. I will demonstrate these in the rest of this webinar. Now I will show you repurposing of a compliance model into a performance model in accordance with TM54 guidelines. I am going to demonstrate this using Design Builder software. I will first review the Part L model, then I will repurpose it for TM54 and show you the various calculation results recommended in the TM. Let's start with reviewing the certification model that I will use here. I will be using this certification model, which was developed by my colleagues from Design Builder in a webinar last month. Those of you who have not seen it can view a recording of this webinar on the Design Builder website. So just to show you where it is, go to training webinars, and you can see the recording of this generating TM5259 reports from your EPC model in record time by Paul Sindovi and Dave Cocking. It will be useful for those of you who are interested in following how this certification model I am using was developed from scratch. In this previous webinar, Paul has repurposed this model for TM5259 overheating analysis. Now back to my model. I will briefly explain the setup of the UK certification model and its settings from the previous webinar so that you can see what has changed in the TM54 performance model. This building is a student accommodation block. It was created in the UK certification mode of Design Builder. You can see this as the DSM icon at the top right corner of the screen. The student accommodation block has 8 ensuite flats, and on the ground floor there is a kitchen. The upper floor is identical except that it has a common room instead of the kitchen. There is a building adjacent to the east of the student accommodation block which will shade and reflect our building. On the site level location tab, the NCM location for London is selected and the associated CIBSE TRY file is set that is required for compliance modeling, basically using the DSM. Model data is set under these tabs. For those of you who are not familiar with Design Builder, it uses a different type of data management system. You can set the most common inputs at the building level, and these are inherited by the blocks and the zones in the level below. This means you only then need to change the data by exception. That is, those data inputs which are different from the levels below. On the activity tab here, we define the internal gains, including inputs like occupancy levels and environmental control set points. Relevant activities have been defined for various spaces throughout this building. So at the building level, I have set the activity as bedroom because that is the most common activity type for this building. That activity type will be inherited by all the blocks and zones below, and I only need to change the activity template in those zones which are not bedrooms. Some of the Design Builder users might notice that there are fewer model data input fields in the activity tab. This is because we are in a DSM certification mode that is specific to UK compliance, which does not allow modifications to occupancy or loads. So the additional data is logged and hidden. You will see the difference between this and the performance modeling shortly when we switch to the full Energy Plus mode, where you will have much more flexibility to input accurate information and not be restricted by NCM default data. A template for timber frame super insulated is selected at the top level on the constructions tab. Loading this template then sets the other construction assemblies throughout the building, such as walls, roofs, and floors. For those of you who are more familiar with compliance modeling, this template uses the energy plus layers data input method. But you could also select simple inference or library options, as Design Builder includes all the NCM inference and library options in its construction database. Now back to the other tabs. Project specific glazing has been defined on the openings tab. For lighting, LED lights have been selected and automatic control using NCM rules has been defined, as you can see here. On the HVAC tab, I have made some deviations from the model used in the earlier webinar. The new HVAC has heating that uses the NCM heat pump electric option. Natural ventilation has been selected. Also, I have made slight modifications to the DHW system to make it more efficient. The default domestic hot water loads were very pessimistic. Therefore, I have defined a new domestic hot water system with realistic storage volume and specified the storage loss. With these settings, we can now see the calculated performance for regulatory compliance. The building meets the regulatory compliance requirements as EPC rating is A21, and if you look at the Bruegel report, then it is a pass. The key takeaway for this webinar here is the energy use numbers here on the actual column. They will be used later when I compare these Part L results with TM54 calculated results. Now, to repurpose this compliance model for performance modeling, the first thing I must do is to change the analysis type from DSM to full energy plus. After switching to the energy plus mode, all of the data which you have input except the lighting and HVAC remains intact. NCM lighting and HVAC data isn't recognized by energy plus, so I have to input those details. To develop the TM54 model, the geometry is already there, so I can move to the data modification stage. This tab is a really good visual indication of the difference between certification and performance modeling. You saw earlier that in DSM mode, all you needed to do was to input the correct template for the activity type, and the other data was logged and hidden. Now you can see you are able to edit all of the data included in the template so as to reflect the actual building characteristics and operations. I will switch between slides and model as now I start making changes. So there are 4 key prerequisites that you need to have in place before you start TM54 modeling. A capable simulation software that can deliver dynamic simulation and allow customizability and model all energy end uses. By discussing with the project team, get an understanding of what operations and maintenance regime will be followed for the building and its system once it is operational. During those discussions, identify the parameters that might change over time or are too difficult to accurately assume at this stage, such as weather, occupancy, and system efficiency reduction. These will help in scenario and sensitivity analysis. Finally, identify the relevant benchmarks to compare the building against, such as those given in TM46 or CIBSE Guide F. This is a step-by-step methodology that is presented in TM54 document. However, when repurposing compliance models, I follow a checklist which signposts me to required changes that are to be made. This is an abridged version of the checklist I use. It is divided into 3 parts. First part is on developing a correct baseline in accordance with TM54. Second part looks at variables for scenario and sensitivity analysis. Last part compares the building against various benchmarks. The first point in TM54 baseline is to check the location weather data. For compliance calculations, you have to use the CIBSE TRY file for the nearest NCM location when using DSM. However, for building specific projections, if more accurate weather data is available for a nearer weather station in a climatically similar location, then you should use that in the baseline projections. Increasingly, more and more location data is available. One place where you can find weather data is the Climate Analytics portal by Design Builder. This tool has weather data from over 28,000 weather stations globally. You can obtain design weather files as well as actual weather data, which is recorded for the site. Therefore, instead of using the default typical NCM locations in the UK, you can choose a station which is much closer to your site. There will be a webinar soon by Design Builder on climate related weather files, where discussion will be done on weather data in general and preview of this tool will be given. Please have a look out for the announcement in Design Builder newsletter and on LinkedIn. So on the location tab on the site level is where you will set an appropriate weather file that you have created or obtained from sources specific to your building location. You will already have it copied into your weather file by accessing the Design Builder weather library, and then you can select it from here. Next in the checklist is the operating hours and occupancy. Intended hours of operation of a building has to be established as far as possible. These are various NCM schedules for a university bedroom space used in the compliance calculations. We see that they assume occupancy during the evenings and no occupancy during the day. Now, contrasting this against the monitored electricity load profile from a couple of student residences at UCL. While total electrical load is not a like-for-like comparison against schedules, however, it can help us in inferring trends. What is clearly visible is that the assumed slump in usage during the day in NCM schedules is not evident in these student accommodations. This shows that there is a need for structured interviews with the client to understand typical occupancy or operating hours along with the way the building will be managed. To represent this, I am going to modify the existing occupancy in my model. So NCM defaults are not suitable for occupancy and operation in our building. And for example, the default density of 0.12 and the area for each flat being 35 square meters, full occupancy will be about 4 persons. However, in our case, each flat will be single occupancy. So I will go and change the occupancy definition to number of people. And write 1 person, and on the at the building level, and on the schedule side I have created a new occupancy schedule. So I will select this and just to briefly show you what the schedule looks like. So basically I have tried to imitate some occupancy, partial occupancy during the day as well. So I'll select that. So now I'm gonna go back to my checklist. Next few steps require modifications to other loads and their schedules, such as lighting, equipment, and HVAC. So going back to the model. Because I have to make multiple changes, I can use a shorter method by using the grid view tool to make those changes quickly. I will select the appropriate layout in the edit mode. I will filter the data by activity type, so I can select all the bedrooms, and you can see that number of people and the new schedule which I had selected earlier is already assigned. I will select all of them now in bulk edit mode and start making changes to the other data items. Now, assuming that the set points for heating will be higher than the defaults, I can change them to 22 degrees as set point and 16 degrees as the setback temperature. Another change I wish to make is to modify the equipment energy use. I will change the equipment power density to 12 watts per meter square, and also equipment schedule to a new one which I have created, which is more representative of the expected energy equipment use in the building. So I'll search for the new schedule, new equipment, and assign it. Besides this, I have also made some other changes, such as hot water requirement to 2 liters per meter square per day, as the original defaults were very high, auxiliary energy use as 2 watts per meter square, and schedule linked with heating, and also change the schedules for heating operations and lighting operations. I will apply these new settings and close it. So for an actual project, you would go into a bit more detail for all the data and modify them as per the information you have got from the interviews with your stakeholders. However, for this demo, this is sufficient. So now I go back to the checklist. So we have updated most of the base data for TM54 projections. Last item in this checklist is detailed HVAC system design. This is not explicitly recommended by TM54, as it proposes a simplified approach to system modeling instead of a detailed simulation, which includes component level system design. This is an example of how a detailed simulation could be modeled. A screenshot from Design Builder Detailed HVAC. A detailed HVAC system should provide better representation of system operation for calculating energy use. This, however, is debatable that modeling HVAC system in more detail at design stage adds or reduces the accuracy and uncertainty of the results when compared to a simplified approach. In my opinion, this decision should be based on the stage of the building procurement at which the model is being created. If the modeling is being done at advanced stages of building procurement, when HVAC products being used are finalized, then at that stage, a proper system modeling might be helpful. In earlier stages of design, it could be avoided and taken up later, because time and cost involved might not be justified. In this case, I am not modeling a detailed system. So once the model has reached this stage, the TM54 baseline model is complete and you can run the simulation. I'll now run the simulation. Now briefly checking the settings. So the analysis is for the whole year. I don't need detailed outputs and I don't want to use the simulation manager. So I'll press start. So in this simulation, I'm only interested in annual fuel breakdown. So I did not ask for more detailed outputs such as detailed internal gains, surface level outputs, comfort, environmental results, etc. and at high granularity for daily, hourly or sub-hourly time steps. I would have done that if I was analyzing the building performance in more detail. Also, it is a good practice to do a proper QA check of your models before you embark on final runs. This can be done by simulating short time periods at high time frequency, like hourly or sub-hourly level, and ensure that the systems and operations are running as they should. This type of sanity checking is, and basically QA checking is essential when doing proper modeling. So now the simulation is over and I can look at my results for fuel breakdown for the entire run period, and I can look at graph and table format, normalizing it by the area. So this is the projected energy use for different end uses based on realistic operating conditions in my demonstration model. Now let's compare these against the earlier part L estimates that we calculated from the compliance model. This is the energy use projection from the part L calculation of this demonstration model, which we saw earlier in the webinar. Now, if we compare it with the simulation results, which we just saw, we can see that the energy use projection calculated in accordance with TM54 guidelines with the building specific modeling inputs highlights the conservative estimates of the part L results for this demonstration building, thus emphasizing the need for realistic baseline modeling and not interpreting compliance results as performance projections. Now, moving on to the second part of my checklist, which looks at the aspect of presentation of results that account for uncertainty. After the new baseline projection, TM54 asks you to undertake some stress assessments and present the results probabilistically. For that, you have to define through your interviews and with your discussions with your stakeholders, the key parameters that may vary between design and operation stage, such as HVAC system specifications, operation protocols, occupancy patterns, etc. This is a typical scenario assessment result sheet from TM54. It looks a bit handful in first go, so I would request you to bear with me as I explain you the key components. You can find it in TM54 and read it in detail later. Also, in the next slide, I'll show you a simplified version of the same exercise. So the scenario assessment sheet looks at 3 key scenarios: low end, mid-range, and high-end scenarios for factors that affect energy use. Low end being the best scenario if everything worked as intended, whereas mid-range and high-end represent decrease in the intended performance. For example, in lighting, the variation in loads, illuminance, or operation hours are the variable factors, and their values are defined for each of the scenarios. The sheet also highlights the influencing stakeholders for each factor. This can ascertain the responsibility to ensure that high-end scenarios are minimized. Adding the scenario results for all end users together, like lighting, cooling, heating, etc., can provide a holistic range within which the building performance is likely to happen. The results can then be plotted in a box plot as seen in the graph on the right. Finally, TM54 also suggests a fourth scenario, worst case scenario, where high degree of mismanagement and inefficiencies occur in building construction and operation. This will inform the project team about the impacts of their actions. So a quick scenario analysis was done for the demonstration model by modifying these input parameters under high, medium, and low scenarios. The simulations were done and the results plotted show that total annual error range, that is low end, mid range, and high end scenarios within the actual performance where it might lie when the building is operational. The scenario results can also be plotted as box plots for different end uses separately. The graph shows that the bar is the median value and the error line shows the high and low range estimates for each of the end uses separately. So you can know which end use is more susceptible for variation. Sensitivity analysis is an offshoot of this scenario exercise. Sensitivity analysis is a study of how variation in model outputs can be attributed to different sources of uncertainty in its inputs, thus helping you to identify the most important and influential variables for the model. By changing one variable at a time in the simulation model, a rough sensitivity analysis can be done to assess which variable affects the energy use the most. This is a simple sensitivity analysis graph from TM54, which shows the effect of changing certain model parameters, such as weather data and operational hours, on the building performance. The magnitude of change can tell that in this graph, the sensitivity of energy used to operation hours is quite high. Sensitivity analysis can help to find the factors that will need more control and checking during the operation stage to ensure that design estimates translate to actual performance. However, more sophisticated tools like Design Builder allow you to undertake these sensitivity and uncertainty analysis very effectively and efficiently. Running multiple scenarios, high end, low end, and all in between in one go, you can get full probabilistic spread of the uncertainty as seen in the chart on the left with the spread within which the energy use will lie. Also, relative importance of variables can be quantifiably estimated by statistically calculating the sensitivities as seen in the sensitivity comparison graph on the right. A multi-parameter sensitivity analysis report can tell which factors are most influential and order them in according to their importance. However, due to time considerations of this webinar, I cannot demonstrate to you how to undertake a sensitivity analysis in the software. Therefore, I will point you out to an earlier webinar which covered this topic. So if I go to the webinars page again, so this webinar, uncertainty and sensitivity analysis, looks at quantified risk assessment using sensitivity analysis and measures the risk which is associated with achieving performance targets. And it uses energy performance contracting project as an example, which was designed to achieve a deck band A rating. The use of sensitivity analysis is shown in great detail in this application. So the final part of the TM54 requirement is to compare the calculated performance against benchmarks based on actual building data. Various sources are available for benchmarks in the UK, such as Guide F, TM46, which have been recently updated. Econ series guides are also there, which are detailed specifically for different building types. These are a bit dated now, but can still be referred to. This is the comparison of our demonstration build against CIBSE Guide F Good Practice benchmark. The building's design projection along with the high-end scenario is within that limit. At this point, I'd like to show you a new benchmarking tool which CIBSE is developing. This is a new benchmarking tool, which is an online version which CIBSE is developing. In this new benchmarking tool, energy benchmarks for various buildings are categorized and presented in a graphical format, and you can plot your building within the data to see where within the distribution your building lies. So to summarize, compliance modeling is different from performance modeling. Transforming compliance models as per TM54 model requires modifications to NCM defaults. Better communication of results by appraising clients of various possible variability can help in design decisions and risk assessments. And this can be further supported by assessing where the building lies among the building stock. So this is the end of the formal presentation, and thank you for your time and attention.
Thank you very much, Nishesh. That was very interesting. We do have a few questions. I hope you can help us with answering a few questions. I'll ask them in the order they've come in. So the first one is talking about the new weather file creation tools you've shown, saying they're really interesting and essential regarding performance modeling. But you didn't mention model calibration, which also requires you to use more realistic weather files. Could you give your thoughts on calibration and how that links to your performance modeling content?
Okay, so yeah, it's a long question. So I think the question is into a few parts about it. So this particular webinar basically is structured around TM54, which is design performance assessment guideline. So you do the calculations at the design stage, and calibration is something which you do at when the building is operational and you're analyzing the operations. So actually CIBSE is developing a new TM which is on operational performance assessment, and that includes a process on how you can undertake model calibration to get the results. And basically, and when you're doing model calibration, then obviously the person who's asked the question is right, that also needs accurate weather data. And to be precise, if you can get, the more accurate it is, the better calibration you can achieve. So that is something, basically model calibration would require this this particular thing. And the second part was that how it relates to the performance modeling which I am discussing now, is that when you would create a TM54 sort of model, you'll be doing at a design stage, and then when the building is operational, you would like to compare what your TM54 calculations predicted against what is happening in the building. So you can compare the TM54 against actual. But then if you want to analyze what is the reason why there's a difference between TM54 and the actual, that is where calibration comes in, calibration using proper methods. And then you can, so once you have created a calibrated model, then you can compare the model settings. You can see what settings you put in the TM54 model, and then the settings you have in your calibrated model, and that can give you an idea of what are the root causes of those deviations, and then help you, and then you can run scenario analysis on a calibrated model to see how you can minimize those and reach to a better operational performance throughout. So this is where this weather stuff comes, and weather is very critical in this specifically. you cannot use generic weather files practically doing calibration model. So that forms a good part to it. Yeah, so I hope that answers the question.
Okay, thanks. Another question is just starting by saying that uncertainty and sensitivity analysis is little known in the UK, maybe because we're so focused on compliance modelling. Could you say a bit more about how uncertainty and sensitivity analysis help with performance modelling?
So basically, sensitivity and uncertainty analysis is a key component when. So the reason why you are doing performance modeling is you want to estimate as realistically as possible what your energy projections would be. And at that time, as every modeling is, it includes lots of assumptions, and therefore you're not very sure that what you actually put as inputs is actually going to translate in the actual building. You can, as TM54 suggests, you can have discussions with the designers and with the stakeholders, which will be the intended occupants or building managers, and then get a rough idea to take them on board that they run the building on how you intend them to run it. But there might be fluctuations, as we have discussed. So sensitivity uncertainty analysis will be very useful at design stage to quantify that, okay, if you have this particular range within which a particular input is varying. So for example, if it is energy use, so operating hours is something which came up in this presentation. So if you know that occupancy patterns might shift and change, you can try and analyze how impactful is that occupancy trend changing is compared to, say, the uncertainty in terms of construction quality you might have in the building. So comparing construction quality versus operation, which is more important? Do you need to, obviously construction quality will affect, but maybe the other thing affects more, and then trying to identify measures that will ensure to minimize those risks. So earlier in the presentation, I showed a graph which had a list of sensitivity parameters which were ranked in order of importance. So for the most important parameters, you want to put more control measures, and therefore it is for providing informed decisions, and also ensuring that you put the right checks and balances for operational stage so that the uncertainty variation is not high eventually. So that is how I would kind of put it there. And to be honest, linking it to the first question, one of the uncertainties is weather. So CIBSE is developing, has one of the things is and for overheating analysis, etc. You would want to model future weather files, and also so that is a variable which you would, and this is something which TM54 also advocates, that you can do a stress assessment of weather scenarios under climate change, how things will change. So I think climate analytics tool will provide you with good amount of data to fill for realistic locations, projections, what has been recorded, what the base files are. So all these things are quite intertwined, I would say, and add value to your overall calculations.
Okay, thanks. Couple of shorter questions, I think. So one is domestic hot water calculated through DSM or TM54 methods?
Can you repeat the question? What is the domestic hot water?
Calculated through DSM or TM54 methods?
So yeah. So I think domestic hot water calculation for you can so the default which NCM gives for domestic hot water in NCM calculations is way is a lot, and that is something which you can modify in terms of what is the storage capacity and type of basically losses which would be there for hot water. So for those, obviously NCM were used, but when you're doing TM54 analysis, you will use, basically it is up to you to get actual understanding of how much would be used and then modify it. So that is why in my model I reduced the domestic hot water from, I think it was quite a bit high, forget the number, it would be in I think 9 or 10 liters per meter square per person. So, and 9 10 liters per meter square per person per day, or 35 square meter flat, is huge, and it is realistically somebody will never use that water. So you would reduce it to a generic consumption for a single occupancy flat and then model it in TM54 analysis.
Yeah, okay, that's good. And a similar line of questioning, just to clarify, I assume that loads such as lifts and escalators were calculated outside of the DSM and would require manual intervention.
Yes, so when you would do a TM54 analysis, your model, when you start repurposing it, you need to add those loads in the model because by default they are not included, and ideally you would want to revise the default loads as well.
Okay, going back to a longer question, starts with some good feedback, starts with great presentation, and then asks a couple of considerations. Is there any chance to develop a working model based on actual energy figures from bills, BMS data and so on, rather than using software? One of the issues associated to that type of study is the cost associated with the energy modelling, making the exercise more time consuming and expensive than some clients might like to pay for. Is there currently a decent compromise between this and what is expected to comply with ESOS, for example?
Okay,
So replacing some of the modeling with actual data.
Yeah, so it kind of links to the calibration question, which I think is the first one or second one. And that is something which I would say in terms of, so there are two different approaches to modeling, and one is building physics based modeling, which does calculations for building physics. It looks at all the heat flows, heat thermodynamics transfers, which like effectively energy plus design builder does. And another line of modeling is more mathematical modeling of results. So, and creating mathematical artificial kind of intelligence sort of models, and then they could be used, they look at trends etc from large sample data, and then they can determine, help you identify, but they work at stock levels. To do the similar thing for a particular building etc, I would say for small projects you would want to do a detailed modeling, and which would be building physics based, because if your intentions are to understand how the building would be performing, how the temperatures would, so building physics model looks at so many variables at one time, and a mathematical model would be designed to look at project, say just energy use, but at the same time you can't look at what's happening with the thermal comfort. So these type of trade-offs need to happen. And in terms of once you have a working model, which is a kind of baseline model for a design, in terms of calibrating it, yes, you can calibrate it based on your monthly bills, and that would give you a good indication. So that will prepare a model for an existing building which is there, and you could basically use lots of the assumptions which were there for that particular building type in your subsequent models. But I would say it's for modeling for the purposes I see where kind of our building services etc lie, this is something which is time consuming, and but I think more and more the tools which are there, they provide more, like for example this model, or for big models when I do modeling, it typically takes about a day or two to finish off the model, right setting. If you've got the right information, then building the model is not that slow. It's about getting the right information for the model in the first place.
Okay, thanks. I've just seen another question, and you might have already answered it with that answer, but you could just say if there's anything more to add, and that is obtaining operational parameters like occupancy profiles can be very problematic in some building types, such as hospitals, university buildings, or a shopping mall. How do you approach obtaining such data? Have you already answered that, or is there any more to add?
I think it's a very specific question on how can you get more realistic operational profiles, and I would say there are 2 or 3 places you can get them. One is one of the links which I shared when I showed the profile for the university accommodation block in UCL. I think this is an open source platform where lots of voluntary loads, etc., are being shared by lots of buildings across the UK. So you could look at the link in the source when you get the slides to access that particular database and get some information from there. Alternatively, one of the things which I have used recently, and I've actually seen some of the students at UCL in one of the design exercises they were given. They looked at this. Google has this trend plots, which is like how busy a place is at any given time. So that information is also accessible through a API, etc. So that is something you can also use to get a bit of information on how typical scheduling is. But most of them would be for, if you're doing assumptions. If you're doing a very building specific thing, have those things in your hand and then discuss it with the potential occupant if you have access to them, or the owners or the managers, and kind of vet it that, okay, is this the typical pattern you want to do? And once you have identified the typical, the main point would be try to do a sensitivity uncertainty analysis on that. Use a low, so have three variations of the same, and then see how susceptible is the building to that occupancy variation.
Okay, that's great, thanks. We are starting to run out of time. I've got a couple of questions, possibly for CIBSE. I'll have to follow up on those after the webinar. But through working on the project, you might be able to help. Do you know when the SimCTM regarding calibrated models will come out?
So the TM, which is for operational performance of buildings, I don't know the exact timing when it would be officially released, but I think it's in the final stages of release. I think if this disruption had not happened due to the COVID, it should have been released around this time. But I think it might be delayed by some time. But in principle, it is as far as I know, it is ready and almost finalized. So it should be released soon.
Okay, so soon, good, thanks. And you acknowledge that TM46 is sort of quite out of date. Could you provide more details about the new online tool promoted by CIBSE? That seems very interesting.
Yeah, so that tool is effectively, if you have noticed, that's like a beta version of the CIBSE benchmarking online tool. And right now, lots of information. So it's a UCL project which is going on developing that benchmarking tool. And within, if you would go back and look at search for it, there is a webinar which was done by Sungmin and Anastasia about how that benchmarking tool works. It is sourcing lots of data which historically has been collected from by UCL and some other organizations, and that has been uploaded there. And it's more like a crowdsourcing sort of thing. So for some building types, there isn't that much data, but for others, there is a huge amount of sample data which is there. They have put in a lot of these deck calculation reports which have been submitted in there. So it would be good to just go to that link and see how that benchmarking tool is developing. I think one point that came to my mind as a follow-up on the last one, which was okay, I think I forgot that, so we can carry on. There's a point that came to my mind. Yeah, regarding the TM, the other TM, I would say I think have a look out at the technical symposium, which is happening later in the year. There might be an announcement in the symposium about that TM.
Okay, thanks very much. I think we better stop it there because we're out of time. So thank you very much for a very interesting presentation, Nishesh, and thanks everyone for logging in for this, and hope to see some of you at the next one towards, not towards the end, this is towards the end, at the start of July. Look out for information on that in our July newsletter.
Thank you, Andrew.
So I'll say cheerio for now.